In previous videos, we have discussed and used abstract methods. In this video, we are going to learn about abstract classes. To review, an abstract method is a method without a body. Looking back at the Java docs, we can see again that an abstract method is a method that is declared without an implementation, meaning without braces and followed by a semicolon. Typically, a class is declared abstract when at least one method in the class is abstract. If we look at this class here, we can see that it is declared abstract here by using the reserved word abstract. If we remove abstract here, we get an error that reads, "The type oil change must be an abstract class to define abstract methods." If we remove this abstract method, reset service light, the error goes away because the only methods that remain in the oil change class have bodies and therefore are not abstract methods. So this tells us if a class contains at least one abstract method, the class must be declared as abstract. Let's go ahead and re-add the reset service light abstract method and add the reserved word abstract here to make the oil change class abstract again. Now, taking a deeper look at this class, we can see it is used to represent the process of changing the oil on a car. We have an int variable named gallons that represents gallons of oil, two public methods called drain oil and fill oil, which simply print a string to the console signifying when oil has been drained and when oil has been filled. Lastly, we have an abstract method called reset service light. This method has been made abstract because unlike draining oil and refilling oil, which we will consider to be the same process for all car objects in this example, resetting the service light that tells the driver when it is time to change the oil may vary depending on the make and model of each individual car object. With that said, as we have learned in previous tutorials, we know that this abstract method must be defined elsewhere in the program, at least if we want it to be of any use. So let's go ahead and do that now. We'll create a new class and call this class SumCarModel. This class will inherit from the oil change class, and we can establish the inheritance by typing extends after the class name SumCarModel, and then we will type oil change, the name of the abstract class that we are inheriting from. Notice right off the bat we get an error that reads, the type SumCarModel must implement the inherited abstract method oilChange.resetServiceLight. What that is telling us is the abstract method resetServiceLight within the abstract class oilChange is undefined. And since this class inherits from it, we must define this method. So let's go ahead and define that method here to get rid of that error and satisfy the compiler. We can simply click Add Unimplemented Methods here, or you can type it out. Notice the error has now gone away. Let's go ahead and cut this method real quick to point something out. If we add abstract after public in this motor class that implements from the abstract oil change class, we get no errors. That is because a class that inherits from an abstract class without defining all the abstract methods of the parent class must be declared an abstract class, which is what we just did here by typing abstract after public. An abstract class inheriting from another abstract class may come off as, well, abstract or hard to make sense of at the moment, but just remember that this is possible and this is how you would do it. Now, here's a good time to show how objects cannot be instantiated from an abstract class. For example, let's go ahead and put this method back in the SumCarModel class and remove abstract here. We'll create a new class called MechanicShop, and we'll go ahead and include the main method stub in this class. Now within the main method, let's instantiate an object from the SumCarModel class. I'll call this object car1. Everything is good, we get no errors. Now let's instantiate an object from the abstract class oilChange. Notice we get an error that reads, cannot instantiate the type oilChange. So what this tells us is, objects cannot be instantiated from abstract classes. Which means if we go into the abstract class oilChange and get rid of everything in it that makes it abstract, so we will get rid of the word abstract here and the abstract method here. Now let's go back to the main method in the MechanicShop class. Notice we get no errors because the oilChange class is no longer an abstract class, and therefore objects can be instantiated from it. But for this tutorial, we're going to have the oilChange class be the only abstract class, so let's get rid of this line of code here. And we'll put back the abstract method here and the word abstract here. Now in the body of this method, we'll add a print line statement that prints 3 steps that will reset the service light on any object instantiated from this SumCarModel class. They will be 1. Step on brake, 2. Turn key to the on position, and 3. Hold odometer button for 5 seconds. Now going back to the main method of the mechanic shop class, let's go ahead and cycle through the three methods available to the car1 object of the some car model type because it inherits from the abstract oil change class. The first is drain oil, the second is fill oil, and the last is reset service light. Now let's run the program and see that all three methods are successfully executed. We can see that right now we have the gallons variable initialized to 0. So the output of the program reads 0 gallons of oil are drained and 0 gallons of oil are filled. What if we wanted to change the number of gallons to be drained and filled on this car1 object? We can do so by implementing a set gallons method to the oil change class. But first, notice we can make the int variable gallons here private, protected, or public. Also, we can declare it as static, final, or both static and final. For this example, we won't want it to be static or final, so let's remove that here. What we will use is a protected int variable, so this variable will be accessible by classes within the default package here or by any classes that inherit from the oil change class, which both cases are true in their uses here since some car model is in the same package and also inherits from the oil change class. Now, to set this variable, let's create a setGallons method that will take an int variable as a parameter, which will be used to set the protected int variable gallons in the body. Notice we can declare this or any other methods within this abstract class as public, protected, or private if we wanted to, but for this example, we will leave them all public. Let's go back to the main method of the mechanic shop class and set the protected int variable gallons before the call to the drain oil method. Utilizing the setGallons method, I'll set the variable to 5. When we run the program now, we can see that the gallons variable of the abstract oil change class was successfully set to 5. The last thing we'll cover is how abstract classes do not have to contain any abstract methods at all. We can actually remove the abstract method of the abstract class oil change and we get no errors. If we go back to the some car model class, we will see an error because of this @override line here, which tells the compiler the method signature that follows exists elsewhere. And since we just deleted the abstract method that has the same method signature, the compiler is saying error. I can no longer find that duplicate method signature. So to get rid of this error, we can just delete this @override here.